The last bit of discussion I want to present about getting data is meant to emphasize the point that a geographic information system is what is often called a great integrator of data. Any data whatsoever that has any spatial component, spatial linkage, spatial characteristic can be turned into a GIS compatible data set, and then it can be added to a GIS system, put on top of base maps, compared with other layers of data, etc. A GIS is essentially the only tool that one could possibly have whereby we could compare wetlands and the existence and extent of wetlands with the locations of migratory bird flyover routes. Those are two data sets that live in different worlds that are the responsibility of different organizations. In a GIS, it's possible to put them together once they are converted all to spatial data. So far, we've seen getting data from the data sites, generally government sponsored. We've also seen how one can take a paper map or a scanned paper map, it became a JPEG, and georeference it, and then use heads-up digitizing to extract information from that old map. Of course, it would be easier if the people had created the map originally in GIS and publicized the shapefile, but we use what we have. Another source of data that proves this integrative capability of a GIS is text data. And I pointed out this particular report in an earlier video. This is a report by the Eastern Flyway Association, and I should probably find a better reference. I could probably research it on Google and find a better reference for the specific person or group who puts this together. I guess it's Brian is the producer of this. But anyway, this is a compendium of observers or observation sites for hawk migrations, and I believe that this is by the species of all the different types of hawks that can fly, and these are the observation sites, and this would probably be, this is 2015. So this is an extremely rich piece of data right here in this form, and I would just love to map this and see what the relative counts are at all these locations, perhaps get a number of years of data and show the change over time, and use these counts to perhaps create some kind of a map visualization of the distribution of these flying migratory birds. The problem is that this is relatively far from being a shapefile. It is possible, however, using a more tedious process than I'm going to demonstrate here, to actually capture this data. There are clearly, by looking at this column, thousands, actually, yes, literally thousands of hours of observations and information captured in this data set right here, and it has usefulness, but it could be even more useful if it was in a spatial format. Well, what we would do is, in order to turn this into a shapefile, would be to get this data and put it in a spreadsheet right off the bat, and it could probably be captured, cut and pasted from this document, assuming one has a good version of Adobe Acrobat, not just the cheap reader. And we do have Adobe Acrobat full power on campus, so it should be possible to extract this information from this table, throw it into a spreadsheet, and then all of that information could be read into a GIS and turned into a shapefile with only one, but a big gap, and that is geographic coordinates for each of these named sites. And that is a bit of a detective job, but it is a very, very small amount of work compared with the amount of work that went into creating this data set, and small amount of work compared with the potential value a researcher could derive from capturing this data in a spatial form. It's a detective's job, or a detective type job. I can get some ideas about these locations by reading the text. Here's a group, or an observation place called Johnny Cake Mountain, Connecticut, and I'm sure that using the Geographic Names Information Service or system of USGS, which you saw briefly in a previous video, I could actually get a coordinate for Johnny Cake Mountain in Connecticut. I could search for it on Google. I could search for it in Google Maps or Google Earth, and I probably could find Johnny Cake Mountain and assign a latitude, longitude, or XY coordinate to it. Plum Island apparently is in Massachusetts, and that's probably findable as well. So all of these things are mentioned, and so probably just by their names it would be possible to track these down. If someone were really doing this, I would, my goodness, oh, here's year by year data. This couldn't be richer than this. This report right here could probably be a master thesis for somebody interested in raptor migration. But anyway, probably the appropriate procedure for capturing this and georeferencing it would be just to ask Brian for, even provides his Gmail address, to ask Brian for a street address of each of these sites, or he may have a GPS coordinate for each of these sites. That may be something that routinely these people have created or captured. So anyway, that's the last bit on collecting data, and I hope that I've convinced you, or at least opened your mind to the idea that pretty much any data set has some spatial component, and you can wrangle it and twist it and enhance it with coordinates and turn anything just about into a GIS data set and answer a question with it. So there's the last of the videos for the term, and I want to thank you for your attention if you've actually gotten this far.